Hello, everyone, and welcome to our first Amazon DocumentDB Focus Day for 2023. Before we jump into our content and tell you all about our session today on Amazon DocumentDB, we'd like to real quickly introduce ourselves. My name is Jason Plank, and I'm a go-to-market specialist on the DocumentDB service team. I've been in the industry for about 20 years and have held various roles such as product management leader, development leader, and obviously my role at AWS as a GTM specialist. I'd also like to pass the microphone over to Doug Bonser, who will introduce himself as well.
Thank you, Jason. So my name is Douglas Bonser. I am a senior DocumentDB specialist solution architect, meaning I focus solely on DocumentDB here at AWS. I've been in the industry for over 25 years in IT and in the solution architect type of roles for going on 9 years now, and working with document databases a lot, and happy to talk to you today and let you know about DocumentDB.
Excellent. Thanks, Doug. Jumping right into our agenda for today, we're going to start, and again, the focus of this Focus Day is really an introduction to DocumentDB. So we're going to start off with why document databases. Then we're going to go into the DocumentDB architecture, and then we'll jump into a service overview. Following that service overview, we'll talk about some of the most recent features that we've released, including some, a pretty big announcement that we had at AWS reInvent around our Elastic clusters. Then we'll talk a little bit about pricing, and we'll close out with a demo, and then ultimately some Q&A. Jumping right in here, as you can see, AWS offers the broadest set of database and analytics services for our customers to lift and shift their database and analytics workloads to the cloud. We've seen customers doing this at record levels across many different areas. The two that we kind of focus on in our Focus Day sessions are really relational databases and non-relational. So for customers wanting to move away from self-managing Oracle, SQL Server, MySQL, Postgres, and MariaDB databases, AWS offers Amazon RDS and Amazon Aurora. For customers wanting to move away from self-managed, non-relational document and key value stores such as MongoDB, Redis, Memcached, etc., AWS offers DynamoDB, DocumentDB, and Elasticache. So, what is Amazon DocumentDB? In order to help our customers accelerate their journey to the cloud, we worked backwards and built DocumentDB from the ground up. Amazon DocumentDB is a scalable, highly durable, and fully managed enterprise database service that operates JSON workloads with ease. We're fast and scalable in that we support millions of read requests per second by scaling compute and storage independently. Our service is fully managed, which means that we automate hardware, provisioning, patching, setup, backups, and other database management tasks. We're enterprise ready. We focus on security. Security is job one here, and our service ultimately offers high availability and durability as well. When it comes to MongoDB compatibility, we are not a drop-in replacement for MongoDB. There's no Mongo source code. We are not taking the Mongo 3.6 server and wrapping a control plane around it. Essentially, we're offering the ability to support hundreds of APIs, operators, and stages within our solution that will allow you to continue to integrate with your applications, drivers, and tools that you might have been using with Mongo. And we'll continue to talk about MongoDB compatibility throughout the presentation. When it comes to DocumentDB customers, Amazon DocumentDB is being used today by a wide variety of customers, from long-standing global enterprises like Capital One, to digital natives like Rappi and Zulily, to game publishers like Habi, and in addition, also several products that Amazon customers use, such as Fulfilled by Amazon, the FBA experience on Amazon.com. They are all powered by DocumentDB. We have customers in virtually every industry, from financial services to retail, from gaming to manufacturing, from media and entertainment to publishing, and more. We welcome you to explore our customer page where you can hear directly from DocumentDB users on why they chose DocumentDB and how it has positively impacted their businesses. The next section we'll get into is a little bit about why document databases. The first reason that customers are looking for, towards document databases is that data is stored in a JSON-like format. That format is flexibly structured and also maps naturally to how we think about modeling data in our applications. We typically don't model data in tabular formats in our heads. We're thinking about groups of things instead. The next reason is flexible schema and indexes. Dynamic schemas can change depending on our data needs and access patterns, so there's no need to design a complicated rigid schema. In addition, indexes can be created and dropped in on demand to meet customer application requirements or query patterns, and can be declared on any field within your documents, including fields nested within arrays. Another reason is document databases have ad hoc query capabilities, which allows you to retrieve specific fields and values and even regular expression queries. Next up, we're going to talk about use cases. When it comes to use cases, Amazon DocumentDB use cases are wide and many, given that document databases offer both flexible schemas and extensive query capabilities. The document model works well with use cases that require complex documents that are dynamic and may require ad hoc querying, indexing, and aggregations. Next, we'll go through some of these use cases in a little bit more depth. When it comes to content management, much of the content that we read today, from news articles to blogs to recipes to patient records, all of that data lends itself really well to a document model since it's dynamic and changing. When it comes to mobile and web applications, there's an obvious connection because a lot of those applications do include or are in JSON. But at the end of the day, it's very easy to store that data that you're collecting, going back and forth between devices because of the model. When it comes to catalogs, this is all about being able to record the output of machine learning experiments, inventory descriptions, pharmaceutical trials. We really see a broad set of customers that use documents for these use cases. When it comes to gaming, we see a lot of customers that are storing user profiles, game management, and matchmaking details. And that's one of the use cases that we'll actually dive a little bit deeper in on our next slide. Personalization is also a common use case. We see customers customize offers based on transaction history or financial data to improve user experiences. In addition, with the scale that AWS and Amazon DocumentDB provide, we're also seeing customers deploy document databases for a much wider range of internet scale use cases, including critical facing e-commerce applications and ultimately IoT solutions. Next, we'll jump into an example of a gaming user profile. So in this example, we have a user, and this user is Sue1942. And let's say Susan decides to play a new game called Exploding Snails. It's very easy to add information to her profile. Notice here that we didn't have to design a complicated schema or create any new tables. We simply added a new set of fields in our document. Similarly, we can add an array for the promotions that Susan has achieved. In this example, you can see that Susan has achieved new user 5% and ultimately snail lover. The document model, as we've kind of mentioned, really enables developers to evolve their applications quickly over time, which are some of the key reasons that we're seeing customers looking at document databases. Next up, I'm going to pass the mic back to Doug Bonser, and he's going to talk about the challenges of scaling document databases. Doug?
All right, thanks, Jason. And now that you understand why you'd want to use a document database, as Jason mentioned, I'm going to dive into the architecture of Amazon DocumentDB in the context of how it addresses some common challenges of scaling and managing other databases. So many traditional databases and Some NoSQL database architectures are monolithic, like you see here on the screen. All right, so on the left side of this diagram, you see client application at the top connecting to this database server. Now, this database server, it's got a monolithic architecture because all these different layers are on the same physical server. All right, starting at the top, you've got the API layer that handles the requests from that client application. Then the query processor, which is going to convert those API calls into queries that the database can understand and executes them. Then typically there's a caching layer that caches information for faster response times, better performance. Logging layer that's going to keep a history of all of the actions executed on the data, right? All of the changes made. And then lastly, a storage layer. The storage layer is going to write data to and read data from attached storage. Now, but this isn't a cloud native architecture. So a lot of times when moving these kinds of databases to the cloud, you're typically going to see multiple monolithic server instances networked together, which in turn can lead to a number of challenges. The first one of those being a challenge around adding read capacity to your database on demand. So let's consider this in the context of a product catalog use case. So your data is not going to change frequently. All right, it's not going to be changing every second, but as your business grows, more and more clients need to read that product catalog. Right? So you've got more and more clients accessing that data at any given time. So you need to add some read capacity. To add read capacity, you add a new node. But because of this architecture, each node has a local copy of the data. So this new node you added for the additional read capacity is going to need a copy of that data too. The only way to do that is to replicate or copy the data from one of the existing nodes to that new node that you added. And this is going to take time, and certainly the more data you have, the longer it's going to take. And then this is also going to affect the performance of the source node. The resources on that node that could be handling client read and writes are now being used to replicate data to this new node. Second common challenge is around recovering quickly from a node failure. So in this scenario, you see that for some reason, node 3 has failed in our database cluster. And to recover, we need to add a new node to replace that failed node. Now, but here you run into the same challenge that you have with adding read capacity. This replacement node needs a copy of that data. So again, data is replicated from one of the existing nodes to the new node, which further reduces the performance of your already impacted database cluster. Third challenge is around scaling storage as your data grows. So let's consider a bare metal deployment scenario with some hard drives attached to a database node. As your data grows in size, you're going to need to scale storage. And this could mean physically removing existing hard drives from your server and installing new larger drives. Or if we're looking at, say, like a self-managed database running in an Amazon Virtual Private Cloud, you could potentially need to resize your Amazon Elastic Block Store volumes, which again requires some intervention and is going to take some time to do that. But either way, at some point, you're not going to have disks big enough to store your entire data set. And then the fourth challenge is around backing up your data. All right, you need to have backups of your data. But how can you do this without affecting performance? So common approach is to use one of the operational nodes to create snapshots or backups of the data, but this can affect the performance of that node. Again, resources that could be handling client reads and writes are now being used to back up data. So common approach to solving that problem is to have another node that is there just to perform the backups. All right, reduces and removes the load from your operational node. But in this case, sometimes there's additional cost for license for that node, and certainly there's going to be additional cost for the infrastructure for that extra node. And then the final challenge I want to talk about is around data durability. All right, and data durability, what I mean with that is it's really data redundancy so that data is never lost or compromised, or having multiple copies of your data. All right, so in a monolithic architecture, The data, again, is local to each of the nodes. So there's really no way to increase the durability of the data or to increase the number of copies of your data without adding more compute resources. So as you see, like in this diagram, the only way that you can have 3 copies of the data is you have to have 3 separate instances or nodes in your database cluster. So now that you have an understanding of 5 of the common challenges around scaling and managing other databases, I want to show you how we address those in DocumentDB. So here's that monolithic architecture that we saw just a few minutes ago. But when we set out to architect a cloud-native database service, we decided to decouple the compute and storage layers. And now because we separated the storage and compute layers, we can now scale each of these independently. So in the compute layer, you've got the API, the query processor, caching, that can scale independently of the storage layer where we keep track of the logging and the actual persistence of the data. So a closer look at this cloud native architecture, right, you see this separation of storage and compute. At the top, you see the compute layer where you'll have 1 to 16 instances distributed across 3 availability zones in the AWS region where this instance is running. DocumentDB supports instance sizes from as small as 2 vCPUs and 4 gigabytes of RAM, all the way up to 96 vCPUs and 768 gigabytes of RAM. There's always a single primary instance, like you see here on the slide. And this primary instance handles all of the updates or writes, but it can also be used for reads if you need immediate consistency in your applications. But the best practice is to use the read replicas, which provide eventual consistency, but you can scale those out to up to 15 replica instances to handle that read traffic. At the bottom, you see the storage layer, and it's a distributed storage volume. So it's not directly attached to these compute instances, and it can automatically scale from 10 gigabytes all the way up to 64 terabytes in size without any user interaction. Provides highly durable storage with 6 copies of the data across 3 availability zones. And whether you've got just a single instance or the 16 instances in your cluster, you've always got 6 copies of that data across 3 availability zones for high durability with DocumentDB. So now that we understand the architecture, talk about how that can help solve these same 5 challenges. All right, so here's that 3 instance cluster, which is a best practice for production deployments. And as read workload increases, you can easily scale the compute layer by adding read replicas. Because of this separation of storage and compute, there's no need to replicate the data set to the new read replica. So because of that, you can add up to 15 read replicas in a matter of minutes. 8 to 10 minutes is a conservative time estimate, with the time required to add replicas frequently shorter, but 8 to 10 is a good estimate to keep in mind. And again, this is regardless of the amount of data that you have in your database, because you're only creating a new compute instance. No data needs to be moved or replicated in DocumentDB when you add read capacity. DocumentDB also allows you to quickly recover from a node failure. In this scenario, you see that our primary instance has failed. And if you have a replica instance, which in this case we do, the cluster failover typically completes in about 30 seconds, again, regardless of the amount of data. And then after that failover is complete, a new replica instance will be created to return the cluster to full strength, again, in about 8 to 10 minutes. Third challenge was around scaling storage. All right, so DocumentDB allows you to easily scale storage as your data grows. And as I already mentioned, in fact, storage scaling is automatic. All right, this storage volume can grow from a minimum of 10 gigabytes to a maximum of 64 terabytes without any interaction on your part. And the distributed storage volume will also shrink as you remove data from your database. The fourth challenge is around backups. DocumentDB allows you to back up data with no impact to performance. Again, because the compute is separate from storage, compute instances do not participate in backups. Backups are handled by the storage layer, so the compute layer remains free to handle client requests. So we have continuous backups that are automatically being handled by the service. And again, there's zero impact, and these can be used for point-in-time recovery and provide a maximum recovery point objective, or RPO, of up to 35 days. With DocumentDB, you can also do full snapshots. There's automated snapshots that are managed by the service. Again, these can be kept for up to 35 days. And you can also take manual snapshots at any time, but do note that you're responsible for managing the lifecycle of those manual snapshots. So again, zero impact backups with DocumentDB. And then the last challenge, if you remember, was around data durability. All right, so when using DocumentDB, your data is highly durable, even with just one compute instance like you see here. This is because storage layer, again, always maintains 6 copies of your data across 3 availability zones. But with a single compute instance, you do have 2 nines of availability, because it will take 8 to 10 minutes to recover from that single instance failure. And because of that, single instance clusters are typically used for development and test type of environments. With 2 compute instances, now you're up to 3 nines of availability. Again, durability is unchanged, but in this case, in the case of a primary instance failure, failover typically completes in 30 seconds, so you would have less downtime with a 2-instance cluster. 2-instance clusters, see them used in production environments that don't have very high read requirements, and also are fine with 3 nines of availability. Now with 3 compute instances, you're up to 4 nines of availability. And again, this is the default DocumentDB cluster configuration, which is recommended for production deployments. And again, in the case of a primary instance failure, failover is typically going to complete in about 30 seconds. Now going beyond 3, like with 4 or more compute instances, you're still going to have 4 nines of availability. Right? So you can't increase your availability past 4 nines. But again, more replica instances are useful for read scaling, as seen earlier. All right, so that gives you an idea of the architecture and how we solve these challenges in DocumentDB. So with that, I'd like to turn it back over to Jason, and he's going to walk you through an overview of the service itself and some of the capabilities.
All right. Yes. Thank you, Doug. And as Doug mentioned, we're going to jump in now to a service overview where we'll talk about some of the capabilities that come with Amazon DocumentDB service. The first thing we'll talk about is the fully managed capabilities that come with DocumentDB. Amazon DocumentDB does offer failure recovery, and meaning that read replicas are automatically promoted to primary in the case of any failure. When it comes to automatic patching, we keep your clusters up to date with the latest patches. When it comes to integration, we do have native integration with several AWS services, including CloudWatch, CloudTrail, CloudFormation, Secrets Manager, VPCs, IAM, and CLI. This is one of the main reasons that many of our customers are attracted to the service. Ultimately, this integration helps our customers simplify their stacks. We do offer pay-as-you-go enterprise grade pricing. So we are billing, by the second, no long-term commitments or upfront fees. Quick message from one of our customers, Freshop, who is an online grocer. Freshop enjoys DocumentDB's backup and scalability to help them manage their workloads. When it comes to MongoDB compatibility, we talked a little bit about this up front. We are compatible with the MongoDB Community Edition 4.0. Within the API compatibility, that allows you to oftentimes use the same MongoDB drivers and tools with Amazon DocumentDB with little or no change. Read scaling is easy with automatic replica set configurations. In terms of that, we're offering DocumentDB supports replica set emulation, where our clusters appear to your drivers to be a MongoDB replica set, which allows you to use driver configuration to easily scale reads. Now, one of the things I I just want to reemphasize is that we are not a drop-in replacement to MongoDB. It's very important that you look at the supported APIs, which you can find in our development guides, and also you can look at functional differences. We will be talking a little bit when we get to our programs and investment section about a compatibility tool that we have. But again, the key message here is we're not a drop-in replacement. We do offer some core functionality that's allowed us to be very successful with our customers. Next up, we'll look at another one of our customers, Enketo. They do inventory automation for SMBs. They're happy that DocumentDB was quick and easy to get started with, and everything, in their words, just worked. When it comes to scalability, you can scale out in minutes, so you can scale up to 15 read replicas. You can scale up, which means you can scale up from 4 to 768 gigs of RAM. We do auto scale on the storage side of things, so you can automatically grow and shrink your storage data sets from anywhere from 10 gigabytes to 64 gigabytes. We also offer load balancing, in which you can scale across many read replicas. The next part we'll talk about is security and compliance. First off, we are integrated with Amazon VPC, and in this sense, we offer strict network isolation with Amazon Virtual Private Clouds. We offer encryption by default, so we have encryption at rest with KMS and customer managed AWS keys, and encryption in transit with TLS. Safe defaults. We offer, when you launch a cluster, you're launching with the most secure defaults. You can optionally choose to modify those, but we do, believe in deploying best practices, and because of that, we do offer, we do launch these clusters with the most secure defaults as we can. When it comes to compliance and support, we have a number of different certifications. Some that are listed here. I recommend you check the developer guide for any more information. But as you can see, we offer PCI DSS, ISO 9001, 27001, 27017, and ultimately SOC 1, 2, and 3, as well as HIPAA. When it comes to backup and recovery, we offer automatic backups, and these are automatic, incremental, and continuous. There is no performance impact. Backups do not affect the database performance, as mentioned, because backups are handled at the storage layer. We do offer 35 days of point-in-time recovery. And ultimately, when it comes to these point-in-time restores, automated backups are stored in S3 for 11.9's durability. And these backups have no impact on cluster performance. You can also archive snapshots, and you can keep these snapshots as long as you need. The cluster snapshots are user-initiated backups of your cluster stored in S3, and again, these are kept until you explicitly delete them. If you'd like, you can also use these to create a new cluster from one of these snapshots. Iron is another one of our customers that create DevOps serverless application tools to manage Docker containers. They're extremely happy with DocumentDB's backup performance and cost effectiveness. And that wraps up the introduction to the Amazon DocumentDB service in terms of some of the actual capabilities. Next up, I'm going to give the mic back to Doug, and he's going to talk about some of the innovation that we've had in Amazon DocumentDB in terms of features and functionalities, as well as walk you through one of our newest features that we just announced at reInvent. Doug, go ahead.
All right, thanks, Jason. And as Jason mentioned, just want to talk about some of the innovation in Amazon DocumentDB. We launched Amazon DocumentDB in 2019, and in the 4 years since launch, as you can see here, we've continued to innovate on behalf of our customers. Right, we work backwards from you, the customer, listening to your needs and requirements, and then we incorporate those into the service where we can. Now, some of the highlights over this time, I'm not going to go into every single one of these, but you see things like role-based access control there in early 2020, ACID transaction support in 2020, 2021, a JDBC driver, geospatial indexes, and then moving into last year, 2022, early in 2022, sorry, we introduced a 1-month free trial. All right, so if you want to get your hands on with DocumentDB, you've got a way to do that at no charge. We'll have 1 month of use with a DocumentDB cluster. We introduced performance insights that allows you to visualize database load with charts that allow you to easily drill into and see what's causing load on the database. We introduced DML auditing, which allows you to log any changes made to the data and take any action on that you may need to. And then lastly, at reInvent, we announced and released Elastic Clusters, which I want to dive into a little bit more. All right, so this Elastic Clusters, as I said, we announced them at reInvent, and this is really the result of this continued investment that you saw on that previous slide in our cloud-native Elastic and class-leading architecture with DocumentDB. Now, so why did we create Elastic Clusters, and what does it do? All right, so we created this to provide a solution for those customers that need to go beyond what a single DocumentDB cluster can provide. So Elastic Clusters provide virtually limitless scale, supporting millions of reads and writes per second, and storage for up to petabytes of data, much higher connection limits for very highly concurrent applications with a lot of users, reduced downtime for patching, rich query capabilities, and still with that MongoDB API compatibility that Jason mentioned earlier. And I want to take just a brief look at how this works. So this diagram looks familiar, right? That separation of storage and compute. And this is what we call an instance-based cluster. Right? If you're looking in the web console or in our documentation, right, we refer to this as an instance-based DocumentDB cluster. And now to support this millions of reads and writes per second and petabytes of storage, what Elastic Clusters does is partitions or shards very large data sets into smaller data sets across multiple nodes, enabling you to scale out your database beyond the limits of a single instance-based DocumentDB cluster. Now, each shard in an Elastic cluster is in itself just a instance-based DocumentDB cluster. They have their own compute capacity. They have their own primary instance that handles updates to the data in that shard and their own distributed storage volumes. And this is how we achieve that millions of reads and writes per second and the petabytes of storage in an Elastic cluster. From the client application perspective, it's just the same as connecting to a regular instance-based DocumentDB cluster. But in this case, we have this request router that you see here on the screen, which is going to route the read and write traffic to the appropriate shard based on the shard key that has been defined when the cluster was set up. So again, this is a new feature that we just released. And again, this is a very high-level overview of Elastic Clusters, but do want to talk about it because it's a really exciting new feature that we've got. And we are going to be diving deeper into just Elastic Cluster capability in a future DocumentDB Focus Day session. So do please be on the lookout for that. All right, so with that, I'll turn it back over to Jason as he rounds up on a few remaining topics here about pricing and migration.
All right, thank you, Doug. Yes, next we're gonna jump right into pricing. When it comes to DocumentDB and pricing, DocumentDB is priced in 4 dimensions: instance size, I/O, storage, and backup. When it comes to instances, these are billed per second, but 10-minute minimums. You can mix and match different instance sizes if you need more read horsepower, as an example. We don't commonly see this, but just like to point out that it is a capability. They do not all have to match, but it's quite common that customers use the same instances for different replicas and primary. You can stop the cluster to stop billing. It does restart after 7 days. When it comes to the second dimension for pricing, it is IO count. The IO count is billed per million, and we're looking. And when you look at this, you have to think about 4 KB writes and 8 KB reads. The system is intelligent to group these operations together, so that you're not doing individual operations when you do have room in the buffers to ultimately group these IOs together. It is very important that you size your instances correctly so that you're reading as much data out of your working set cache and not fetching from storage. Because obviously these will cause IO operations. The next component is storage. So we bill for 1 copy of your data despite writing a total of 6 copies. So if you write 10 gigs of data, you're not getting billed for 60. You're just getting billed for that 10 gig data set. When it comes to the fourth dimension is backups. Backups are free with Amazon DocumentDB up until the size of your data set. So if your data set is 10 terabytes, you have the ability to do 10 terabytes of backups for free. And again, these have no impact on your cluster and they consume 0 IO or compute resources when you're running backups on DocumentDB. When it comes to migration methods, we generally have 3 migration methods. The first one is what we consider offline, and this is the simplest method, but sometimes does cause longer downtime. And this method uses MongoDump and Mongo Restore tools to ultimately migrate data. The second method is the online migration using DMS. This provides a 0 downtime migration, and ultimately what we see customers often do is really look at combining these into the hybrid method where you're merging both together. It's a little bit more complex and there are more moving parts, but allows you to speed up your migration a bit and essentially use MongoDump and Mongo Restore to migrate the data, and then DMS to replicate changes. The last topic that we're going to talk about is the different Amazon DocumentDB programs and investments. When it comes to helping our customers accelerate adoption of DocumentDB, we offer a number of different programs. Number one, our specialist solution architects maintain a cost analysis and a compatibility tool. The cost analysis tool is used to ultimately generate cost estimates of your workload on DocumentDB. The compatibility tool is used to assess whether your current deployment can be supported on DocumentDB. So as you're looking to migrate from MongoDB, you would ultimately use this tool. We recommend, generally speaking, as a lot of our customers that ultimately are consuming DocumentDB are migration customers that have migrated. We definitely recommend that you use the compatibility tool as on your source side, so that we can ensure that we do have coverage in terms of features and functionality as you look to migrate to DocumentDB. The next program that we offer are immersion days, and these are essentially based on your needs as the customer. These are typically half-day or full-day training events with plenty of hands-on labs, and we tailor the agenda, as I mentioned, around our customers' needs. Another program that we frequently engage in is our well-architected lens. A member of our technical team will ultimately offer an assessment focused on optimizing performance, reliability, security, cost, and operational excellence. And this is something that we see and engage with on our customers, as I mentioned, very frequently. There are some other programs listed here, and I'll just touch on one quickly. We do have a dedicated professional services team. Our AWS ProServe team has been instrumental in doing a number of migrations for some of our top customers. So that's another thing that our customers ultimately like in terms of investment. You do, again, we have a dedicated Amazon DocumentDB ProServe team to carry out assessments, migrations, proof of concepts, and etc. All right, and at this point, I'm going to go ahead and transition. We're going to transition back to Doug, who is going to do a demo for us. But I don't like that. 3, 2, 1. At this point, that'll wrap up the content and presentation portion of our Amazon DocumentDB Focus Day. But I will be transitioning to Doug, who will ultimately be doing a demo. Doug, do you want to go ahead and tell everyone about the demo and take it from here?
All right. Yes. Thanks, Jason. So I'm going to spend a couple of minutes with a walkthrough of DocumentDB and show you some of the things in the console. So first is how to get to DocumentDB. So if you're signed into your AWS console, you could simply search for DocumentDB. Go ahead and click on Amazon DocumentDB, and it'll take you to the DocumentDB console. Now, in my case, I already have a cluster that I've created here in my VPC called Getting Started. But I want to just quickly walk through creating a new cluster so you can see what that looks like. So the default is an instance-based cluster, like I mentioned previously. You can see the Elastic cluster type here as well. Again, as I mentioned, we're going to have a future session diving deeper into Elastic clusters, so we'll go into that in depth then. But for now, I do want to focus on an instance-based cluster. So I'm just going to call this live demo. The default engine is 4.0, so DocumentDB version 4.0. Instance class, right? If you remember, I mentioned those instance classes when I talked about the separation of storage and compute. This is a relatively small R6 or Graviton2 instance with 2 vCPUs and 16 gigabytes of RAM. For the purposes of this demo, I'm going to stick with that. And you see that the number of instances does default to 3, which is our recommended production cluster configuration. Other things you need to provide are a master username and a password. And I still can't talk and type at the same time. And that's it. That's all that you really need to provide to create a DocumentDB cluster. So just a few pieces of information. Now, there are some advanced settings or some optional things that I'll walk through some of those right now so you can get an idea of what they are. The first is which virtual private cloud or VPC do you want to deploy the cluster in? So it is going to default to the default VPC. In my case, I've got a separate VPC I'm using specifically for this, so I'll choose that. Next is which subnet group. All right, I mentioned early on in the architecture that the compute instances are distributed across 3 availability zones in the region where you're deploying it. And that's really driven by this subnet group that is defined. So this lab VPC subnet group has the different subnets and the 3 availability zones in my lab's VPC. So that's going to be used to deploy the compute instances into. And then the security groups. Jason mentioned that it's secure by default. It's a VPC only service, meaning that the only way to access DocumentDB cluster is via a client that's in the same VPC or another VPC. And you do need to configure the security group to allow access. So it is secure by default. So you're not going to accidentally create a DocumentDB cluster and have it exposed to the public internet. So in this case, I'm going to choose the security group that I've defined to allow access in to the DocumentDB cluster. Moving along with the optional settings here, the default port is 27017. Cluster parameter group. So parameter group is where you specify things like, do you want to disable TLS, right, for encryption in flight? Again, that's enabled by default, secure by default. If for some reason you wanted to disable that, you would do that through the parameter group. All right, so we're going to stick with the default where we have all the secure best practices. Encryption at rest. Again, default, secure by default, it is enabled, and it'll use a default KMS key that AWS provides. If you have your own keys that you need to use to encrypt your data, you can use those as well, but I'm going with the default. Backup retention period. All right, we mentioned a couple of times you can have a retention period up to 35 days. The default is 1, and you can't turn it off. There's no 0 option for backups. So again, by default, we want the data backed up. And when Jason was talking about pricing and with backups, right, we don't charge for basically 1 day's worth of backups or backup space equivalent to the size of the data set. So good way to think of that is you get a day's worth of backups for free. So 0 impact, 0 cost if you go with the defaults. If you do increase the retention period, you will incur some backup charges, but again, it's all 0 impact. You can specify the time window where you want the automated snapshots to occur. All right, this is once a day, a full snapshot of all of the data. You can specify a time window, and right now the default is anytime within 30 minutes from midnight UTC. All right, the service will start creating that automated snapshot. Performance insights, I mentioned that earlier. It's a way to visualize load on your database cluster. That is disabled by default. If you want that, you can turn it on here, or you could also enable it after you create the cluster. Log exports, I mentioned DML auditing, or we're talking about the innovation and features, and that's the audit logs. And profiler logs, another way to think of that is a slow query profiler. So these are off by default because they do incur some extra overhead with the additional processes that need to run to gather that information to create the logs. They are off by default. If you want to turn them on, you select them, and you can export that data for DML auditing and for slow query profiling. If you have a specific maintenance window that you want for the service to apply patches, you can specify that. The default is no preference, and the service will apply those patches based on its schedule. Any tags, I always recommend using tags on resources in AWS so you can track what is being used for different projects or different teams. I'm not going to specify any tags here. And lastly, with that secure by default, deletion protection is enabled. All right, so you can't just go ahead and accidentally delete a cluster. You do have to uncheck this, and at that point you can delete a cluster. I'm going to go ahead and create a cluster with the settings that I have here. And this is going to take about 8 to 10 minutes. Again, going back to that time it takes to create a compute instance. But I'm going to now just take a few minutes and step through an existing cluster so that you can see the types of information that you can see about your cluster once it's been created. So I've clicked on my cluster identifier, just have a summary. Here's the version, the cluster is available, all 3 instances are available, there's no pending maintenance, and my parameter group is in sync, right? Again, parameter group is where you can set things like, do you want to disable TLS, things like that. Connectivity and security. This is a go-to place to get all the information you need to know and that you'll need to use to be able to connect to your cluster. So you do need to download a certificate, a .pem file that will be used to connect to the cluster. So there's the wget command for that. If you want to use Mongo shell, you can just simply copy and paste this connection string here. And from your application code, here is the Mongo URI that you would use to connect to the cluster. So you've got everything that you need right there to be able to connect. Instances tab, got a little bit more detail on the 3 instances in the cluster. You see there's a primary. We always have a single primary. And in this case, we have 2 replicas. We can see that they're R6G large. They're all available. Here you can drill into the configuration. So you can see the cluster endpoint. All right, that is used when you connect to the cluster. All right, and that's going to be embedded in those Mongo connection strings and the Mongo URI that I just showed you on the connectivity tab. You can see the master username, the port, the parameter group, the backups. In this case, backup retention period is configured for 7 days on this cluster, and it's telling me the earliest restorable time for point-in-time recovery. So in this case, it's earliest, yeah, so that's the furthest back I can go. Latest restore time is I can restore to about 2 minutes ago. Sorry, I always get the earliest and latest mixed up there. My backup window, maintenance, there's my maintenance window, and the security group, and TLS is enabled. All right, so a quick overview of all of the specifics for the cluster. Monitoring tab, this is where you can get a view of over 50 different CloudWatch metrics related to the cluster. So how much data is being stored. In my case, I've got about 60 megs worth of data being used. The CPU utilization, freeable memory, go down to things like throughput, where we can see the writes per second, the read IOPS, the write IOPS, around latency, the replication, right, between the primary and the replica instances within the cluster, as that data is updated. Operations, not really doing anything on this cluster, but these op counters, you can see, well, how many queries, how many deletes, how many inserts are occurring per second. And then lastly, system level statistics around what we call cache hit ratios, which again, we will go deeper into these in future focus days. But just a quick, easy way to get to all of the important metrics and statistics about your cluster. And then lastly, events and tags. I didn't define any tags. Events, you can see any events that occurred on the cluster. All right, so you can see that there was a failover earlier because I was doing some changes in the cluster and actually brought the primary down. So it did a failover. You can see a record of those actions here in the events. All right. Snapshots. When I was talking about backups, you see the different snapshots that have been created. You see that there are automated snapshots here and a manual snapshot. Again, these automated snapshots are taken every day, right, around the same time based on my backup window. As you can see here, they're all roughly around 7:10 p.m. UTC. And then here's a manual snapshot that I made. So automated snapshots, the life cycle of those is managed by the service. Right? So once they get past the retention period of 7 days, that one that's 8 days old is going to automatically be deleted. This manual snapshot will stay out here until I delete it. Right? The service does not touch your manual snapshots after they're created. All right, and that will do it for this overview of DocumentDB. Again, just want to reiterate, we'll be going deeper into features like elastic clusters and some of the other capabilities where we will dive more into the DocumentDB console in future sessions. So please keep an eye out for those. And with that, myself and Jason would like to thank you for your time and attending, and we look forward to speaking to you again soon.